All right, so at this point, you've probably already done the first part of the notes, and now we're going to move on to the next. I can show you a picture of what that looks like. One moment. Okay, awesome. So at this point, you've already done the periodic table section of your notes. There's two sections that are coming up next, atomic structure and atoms. We're going to focus just on atomic structure for right now. You can do these notes either before or after the build an atom simulation lab. Doesn't really matter. I would definitely say do this before your atoms notes though, because it's kind of an introduction that'll help you get there. So just to get you in order and where the context of where we're looking at right now. All right, so let me pull up my notes. Okay. So for this section, there's not a lot of words for you to write. I've already put them all in for you, but I'll kind of I'll talk about this a little bit. So if you all could draw this model of an atom, okay? This is a specific type of atom, and we're going to go through a whole bunch of vocabulary words that are relevant to this section. So the first word is subatomic particles. So sub means below, atomic obviously means atom. So any particles that are smaller than an atom. An atom is the smallest unit of matter that still retains the same properties. If you break an atom apart into smaller pieces, it no longer will retain the same properties of the original material. So for example, gold, you can keep dividing a little piece of gold smaller and smaller and smaller and smaller until you get to the gold atom. At that point, if you break it up into pieces, it won't be gold anymore. There are smaller pieces, but they no longer represent those same properties of that original material. So atoms, including gold, are made up of smaller things, and there are 3 of those subatomic particles. The word subatomic particle is just really helpful for us so we can talk about these things in general. There are protons, neutrons, and electrons. Those are the 3 subatomic particles. So you can label them on your notes right here. Protons are positively charged, and they're located in the nucleus. So the nucleus, as we'll see right here, is the center of the atom, and it is right in the middle there. So these 2 red ones are the protons. So you can label those. Either you want to draw an arrow or a little arrow off to the side to label protons, however you want to do it. So maybe connect the dots there, make a separate note, however you want to do it. Protons are located in the nucleus, and they determine the identity of the element. So this element has 2 protons. So we can figure out that this is, you guys can probably guess what element that is. It's actually, it's helium. You may have guessed it. So this is helium. If we add more protons to this element, excuse me, to this atom, it'll still be an atom, it just won't be helium anymore. So if we added a proton, it would become lithium. If we removed a proton, it would become hydrogen. So that's how protons are super, super important. It determines the identity. There are, yeah, all elements are atoms, but each atom is a specific, can be categorized as a specific element. It's like a type of atom, essentially. Okay. The next subatomic particle are neutrons. Neutrons also are in the nucleus, but they do not have a charge. They're neutral, which is why they're called neutrons. In this case, they're represented by the green circles. Neutrons and protons both have approximately the same mass. A neutron weighs just a little bit more than a proton. And neutrons are really important because they determine what isotope an element is, which is something we'll talk about in the next set of notes, and also determine stability. So this particular isotope, or this version of helium, is very common. It has 2 protons and 2 neutrons, and it's very stable. If we were to remove one of those neutrons or add another neutron, we could still have helium, and it might even still exist in nature. It just wouldn't be as stable. And we're going to talk again more about that when we get to isotopes. So you can label those as neutrons. The next is electrons. So electrons are negatively charged, and they are not located in the nucleus. Instead, they exist around the nucleus. This is an orbital or Bohr model. So it kind of suggests that these kind of orbit like planets. That's not really true at all. It actually is completely untrue. But it's a good enough way to conceptualize it for now. These are very, 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 very tiny. In terms of, electrons are super, super small. They exist outside of the nucleus in what we either call an electron cloud or shells. We're going to talk about both of those more a little bit later. They're super, super tiny and are negatively charged. And they help determine if the atom is neutral or charged as a whole, which again, it's either an ion or not an ion, and we'll talk about that in later notes. So when I think about, I'm going to attach this video with some other YouTube videos that will really help you with these concepts. There's some very good ones. But when I think about an atom, atoms are actually mostly full of empty space. They're full of nothing. Not like air, because air actually is full of atoms, but like absolutely nothing. So if you took an atom and you zoomed in enough that, like, I imagine it like this helium atom filling like a football or baseball stadium, like a huge sports stadium, like that could fit 10,000 people in it. So if we did that and we looked at this and we said, that's now the size of an atom, and the very, very center of the stadium, you would find 2 Skittles and 2 M&Ms. Those are going to represent our protons and neutrons, because Skittles and M&Ms are kind of the same size, but not exactly. So like your Skittles are a little bigger than your M&Ms, so they're the neutrons, and your M&Ms are your protons. So there's 4 of them, and they're all clumped together in the very, very center. On the very outside of that stadium, like all the way on the outside, would be 2 grains of salt, tiny little grains of salt. Those represent your electrons. Electrons are tiny, protons and neutrons are quite a bit bigger. Everything else is empty space. Yeah, and it's crazy. Electrons, they don't orbit. They just kind of like exist in the sphere all the way around, and they move so fast, in fact, that even in that model, those 2 electrons would be moving so fast that you would not even be able to enter the stadium, because it may as well be an invisible brick wall, because those little grains of salt are moving so fast you would just hit into them if you tried to get in. Electrons are weird and they're amazing, and I love them. We'll get into that more later. Okay, so that is all that you really need to know about atomic structure for right now. And we'll continue on in the next one with atoms and a couple of other things. There is no unit packet pages for this yet. This is just good information to have for right now. And we'll go forward to the next video. So there you have it. See you next time.